आइए जरा इस वीडियो में हम एनसीईआरटी बेस्ड एक न्यूमेरिकल करते हैं दैट हैज बीन टेकन फ्रॉम द सेमीकंडक्टर चैप्टर एनसीईआरटी. सो इन द फॉलोइंग फिगर shown below, the value of beta is 100. Find IB, VCE, VBC when IC is 1.5 milliampere. The transistor is in which mode? So this is the given circuit. This is the base. This is collector. This is emitter. This is equivalent circuit. This is 220 kilo ohm. This is 47 kilo ohm. This is NPN transistor. So the first of all the given data is there is collector current is 1.5 milliampere and beta is 100. That is, beta is defined as the ratio of the small change in collector current to the small change in base current, or you can say in case of DC IC upon IB, and cross multiplying IB comes out to be equal to that is 15 माइक्रो एम्पियर. आप इसको कन्वर्ट करेंगे, ये मिली एम्पियर है, ये 3 जीरोज है, ऊपर जाके -6 हो जाएगा, ये माइक्रो हो जाएगा. देन फॉर सेकंड केस दैट इज वी आर टू कैलकुलेट द VCE. That is the collector voltage between collector and emitter from the various formula, or in this case you can say that VC is equal to VCC, that is the applied voltage along the across the collector minus the voltage drop across the resistance connected in the collector circuit. This comes out to be equal to 16.95 volt. Step 3 for VB, we are to calculate the VCE, और हम VB भी कैलकुलेट करेंगे ताकि VBC हम फाइंड आउट कर सकें. सो VBE के लिए आप देखिएगा VCC इज इक्वल टू IB इंटू, यू कैन से दिस इज RB एंड प्लस VBE. So this VBE from the KVL can be calculated. किर्चॉफ्स वोल्टेज रूल आप यहाँ लागू कर सकते हैं. VCC और ये सर्किट लेंगे हम, दिस इज VCC एंड दिस इज 220 वोल्ट IB, और VBE इस केस में हम ये लेंगे. सो 24 इज इक्वल टू 15 इंटू 10 टू पावर -6 टू 20 10 टू पावर 3 प्लस VBE. इसको इधर कैलकुलेट कर लीजिएगा, ये आएगा 20.7 वोल्ट. नाउ वी हैव टू फाइंड आउट द नेक्स्ट, that is the fourth point, VBC. VBC is the direct difference between the voltage at the base and the collector, that is 20.7 minus 16.95. It comes out to be equal to 3.75. Now the very important point, we have to calculate whether the which transistor is in which mode. There are 3 modes of operation of the transistor, that is the active mode, saturation mode and cutoff mode. So in this case you see that voltage between base and emitter is greater than 0.7 volt. Yes, this is VBE. So barrier voltage overcome, and this is forward biased. Similarly, the VBC is also greater than 0, and therefore base voltage is greater than collector voltage. Both junctions are forward biased. ये collector emitter junction भी और base emitter junction भी forward biased है. So in that case, the transistor is in saturation mode. That is the current flow करेगा, IC will flow, and transistor is in the closed circuit, or it is in the saturation mode. So in these types of numericals you have to apply the KVL, and if a need is there then the current rule पे apply कर सकते हैं. डायरेक्ट फार्मूले की एप्लीकेशन है, कैलकुलेशन है. थैंक यू वेरी मच फॉर वॉचिंग द वीडियो.